back fondly upon the very first day that I got my first word salad badge. It's such an accomplishment, when you're
I do
talking to
too, Stone.
Globies,
I remember too. Yeah.
when they outright admit to you indirectly exactly how ignorant they are, it's a joy.
Somebody threw an insult at me the first time that was like, "What do you like, Witsit?" And I was like, "Oh, thank you," because I was
Thank
brand
you.
new and hadn't talked to anyone. I was like, "Oh, what a compliment! I must
Wait,
be doing it
I didn't
right."
have my dick in my hand. Say it again. Oh,
And they say
The,
that because
they
you
held it, yeah,
on
as
it.
if it was an insult. Then it was like, "Oh, you mean that I spoke really like coherently with logically cohesive, correct words with lingo? That's great, nice."
Hey, Stone, was that when you grilled that one guy in a presentation on FEF, Fighter Friday? That guy at social media. You remember that guy?
it was. I'm so glad you also remember it.
I knew it would. That was the best
I will
presentation. And he was
cherish
in our
that.
he was in our space that week before, and he was just all riled up. And you just put him in his place, and that was the greatest thing ever. And he was really new to the conversation, but he was all rambunctious and gung ho, and you just sat him down like a toddler. So I remember that.
It was such a pleasure. Yes, thank you again.
A couple years ago, there would only be maybe 5 or 6 people in this space, and now there's 100 listening in. Let's get this space liked, retweeted, because I think a lot more people these days are starting to wake up. They've been lied to for lots and lots of years. The math isn't mathing up, and the truth is starting to come out.
Come out.
Come out.
I was gonna say that.
It's going to come out for a ride in your boat.
Hey, this is the other thing about being Canadian. You get sold a climate change crisis with only 41 million people in your entire country, and it's enormous, and everything's green. It's lovely.
It is funny. They actually wrote a book about that. If it's like the Club of Rome put out a book that was like, "Hey, how do we blame all the world's problems on the people themselves?" And they were like, "Oh, you know what? You know what could be that you are the problem because of the climate, and then we'll blame them." They like literally like speculated and then like told like a fictional story and then put it in a book that they were going to do it, and then 10 years later they enacted it on the public, and people are like, "Oh, I guess if I pay carbon taxes, the weather will be gooder."
Well, it's the
It's
best
like,
mark. Yeah, it's the best marketing, right? Because there's a hurricane. Oh, climate change. It's cold out maybe the next season when it's supposed to be a little bit warmer. Climate change, and they can just always use that as a narrative to generate fear to just to say, "Hey, give me your money." And I don't know. A lot of the world is starting to wake up. I'm glad the U.S. is starting to get out in front of it and say that they're calling it for what it is, really.
Well, you remember when it was the other
well,
way? That the needle was totally swinging in the other direction in terms of public. They were talking about global
I
warming.
do.
Global
Yep.
warming was the threat for so long, but isn't that absolutely wasted energy on a population who live north of 49, who are constantly freezing their fucking asses off? And you're like,
Thank
global
you.
warming, dude. I'm like, yeah, sign me up. I'm going to buy an extra car.
Yeah, like how much land would you actually open up to vegetation and growing more crops and opening up more land
Tourism,
for food?
precisely.
Like
Man,
it's hilarious,
they're
right?
they're telling us that it was global warming. They changed it to climate change. But global warming, it was like, oh no, hairspray! You guys are using too much Aquanet there, and we had some big hair, so it was like a legitimate. We kind of believed that shit because there was a lot of fucking hairspray. I ain't gonna lie, man. Fucking 80s was crazy. But you got Al Gore that saying, oh, all the ice caps are gonna melt, and we're gonna lose all the polar bears and stuff, and he's got a mansion with like 6 ACs on it,
Dude, he's
and
got three.
Hairspray.
it's like
Hairspray. Nothing global warming.
and we got lots of polar bears and a lot of ice, and it's pretty cold up in Canada still, right?
Yeah, and I'm pretty sure I don't know, the ice caps just grew ice for the first time in a bunch of years. I don't have the study out in front of me or the article, but
Oh, you
that's
don't
what
need
I
it.
read.
The polar bear population over northern Russia is exploded. They're having hunting seasons and shit because the bears are moving in and taking over. They're kicking the humans out there, so many of them. It's like, oh, now I see it. All right.
Moral of the story: if it was to get warmer, that would be a blessing, my opinion.
Is it climate change or is it climate control? They want to control the weather. And, that's something that we should kind of, talk about with, everything that we've been talking about tonight is how they're manipulating our weather, with the floods. They said it was fires, but we know how they all started, So what do you guys think about that?
Yeah, I think they do weather modification.
You forgot harp.
Yeah, hard.
Yeah, it's easy to make you're the bad person. When if you don't think you're the bad person, we'll just make it rain harder. Or like, hey, you guys like food? Well, how about this heat wave? Oh, it doesn't last that long. We'll just make it last a little bit longer. You guys like the Dust Bowl? Okay, we're gonna make it another Dust Bowl. So like,
You
oh,
know,
you're not
I believe-
listening? Listen harder. It's a great tool.
and even in they said it in Forrest Gump, man. And then one day it started raining, and it lasted for like 6-8 months or something like that.
That's how the Noah's flood started in the Bible.
I've seen they've done that in
You
Canada a bunch of times this summer, and it was very noticeable. They start spraying the skies. They never used to do that, and then all of a sudden clouds start rolling in. And midsummer, in the warmest places, you'd start to see hail chunks on numerous occasions, and that was very uncommon. And I don't know, coincidence, spraying the skies. But the other thing you got to keep in mind is the aluminum content that uh, those planes are admitting, and then that's going into agriculture, which is then getting shipped off to you and I. So it's not good for your brain either. So it's
Oh
something
no,
to
the smurfers are
address.
talking about contrails. I love
Yeah.
that. I love that for you. I guess my mic's working now.
Ooh, it sounds like
Yeah,
a
two
Glover.
things.
Welcome, bud.
Hey, hi. Well, two things. One, the hairspray thing with chlorofluorocarbons. Nothing to do with global warming. Has everything to do with the ozone layer. So those are two separate problems. But what you were
Yeah, we
talking
burned a
about,
big old hole in that bad boy, man, with Aquanet.
yes, it's getting better now because we pretty much reduced to the use of those products.
Just real
We-
quick, man. Real quick, what shape do you think the Earth is?
Well, I think you just proved that the Earth is a globe by that long answer.
Well, I think I could tell right away you were a Globy the way you came in the conversation, tried to hijack it, and then what do you mean? I asked you a simple question, man. Are you all offended because you can't provide any evidence?
Well, why are you muting me in the middle of my response? You asked me a
Oh,
question. And you got,
I knew that was. I knew
you got
that was
really
going to be
upset
your
all of
response. I knew that was going to be your response. Just try to chill out. Yeah, I'm going to pass it off to Cage. Go ahead, Cage.
So why is it you think what proved it was a globe? What?
Am I going to be allowed to speak now, or are you going to mute me again really quick before I answer?
I told him to back off on that, man.
Okay, cool.
You
Thank
you have the reins. Continue on, good sir.
Yeah, so the answer you gave before, where you're talking about the ratio of miles to arcs in the to like arc seconds, I guess, in the sky will vary depending upon the latitude that the observer is at, right? So a global model predicts that. A flat Earth model doesn't. You just conceded that we have a global model. So like I think we're done here, actually.
So would you like to? Who was the one that brought that? Was that Alan
Yeah,
or
Green, you're just not paying attention to the points being made, man. Or you don't understand them.
Illuminate
That's
it.
what you're telling
So
us.
explain how that works in your model then, please.
What are you trying to say that we can't have
Silence is
elevation?
deafening.
We
The
can't. We
floor is
can't
yours.
have.
Please explain how a flat Earth
Are you going to
model
talk right
will
to
account
me,
for
or
that.
what, dude?
Are you guys talking about?
I'm-
Are you guys talking about how the stars change positions, like 60 nautical miles per degree? Is that what you guys are talking about?
is that
Yeah.
what you're questioning there?
Oh, perfect,
Green?
perfect. So our assertion is that that's an optical phenomenon based off of a radius of vision, and it's just mapped to the same thing. So often when you guys see something, setting into the horizon, you'll be like, oh, it's a globe or whatever. And if you see it above the horizon and its true position is below the geometric horizon, it'll be mapped to negative coordinates. But its apparent position, the position that you see, will be quote unquote astronomically refracted up. So they have a value for that. So you guys will be like, okay, well, the real position of the star relative to the observer it's below Earth curve, but it's also being lifted up above Earth curve. And what you can do is you can go into like Stellarium or whatever your favorite astronomy tool is. You could pick a star that sets and have it set into the horizon, and you can turn on and off refraction, so you can toggle it on and off to see the difference between the true and the apparent there. And what you can do is you can get the true position down to like negative 30 something arc minutes, and then the apparent position will finally be negative 1 arc, will be negative coordinates as well. So they're saying that basically as the true position of a star gets would be lower than the actual physical Earth, based on where the observer's at, that it's being lifted up by this astronomical refraction correction amount. And what we've done is we've come up with a way to test that and see if it's true or not by using mountains to occlude the star. Because if both of our positions are that the stars, the way that we perceive them, if that's just an optical effect versus due to the ground being curved at the same rate, then just watching things set into the horizon won't tell us anything unique. But when we have mountains that have, oh fucking hell, it just disconnected me.
No, you're good.
No, we hear you, dude.
We're still there.
You're still there,
Did you hear
man.
me? Did it? My back? Okay.
Yeah, you never
Yeah,
left.
my
You never left. You're still there.
Oh, okay. It did the thing where it refreshed me out. Okay.
Yeah.
So anyway, by using mountain peaks, because those are going to have a specific elevation that's model dependent. So flat Earth would predict no drop over distance, whereas globe would predict some amount of drop over distance based off of the distance between you and the mountain peak. And you could figure all that out using central angle theorem, which is our preferred method of doing it, because then we get exactly what the globe quote unquote predicts, etc. So anyway, that's so weird that it keeps refreshing. Are you guys still hear me though? It just did it again. I just want to double check.
Yeah,
No,
for
you're
sure.
good.
It's going to keep dropping the window down and up, and because you have my compression off, you know what I mean? Like we did the switch. That's as far as the bug goes. We've stopped it in its tracks. So,
wow.
Let it do its little twitchy thing and just ignore that shit. We all hear you.
Thanks,
So,
Elon.
so Green, are you going to demonstrate you weren't listening by asking the same question, or what's going on here?
Well, let Alan finish.
Yeah, I almost reached the point. So if we're using a map and astronomer tools that are based off of mapping the position, like how we see the stars based off of either time or distance traversed, then just watching the observation alone can't tell us anything. But because the occlusion timings based off of the elevations of mountains give us a way to distinguish between the two models, because the stars are going to be occluded at different times for each model. Because if you're an observer on a globe, then the mountain peak is going to be, let's just take 200 meters for an example. The mountain peak is 50 kilometers away, so it's going to be 200 meters lower than you. So what that means is the true position of the star is going to intersect with that mountain peak way before it would on a flat Earth, because the cause of the star changing elevation is the Earth curvature between you and the mountain peak as the Earth rotates away. So it's a physical elevation change that the globe is claiming based off of that. So they predicted an earlier time. And what we found through, I think, what is it now? 9 different peaks with like close to 50 measurements, because some stars will hit the same peak over and over again, so we could get an average or whatever on that. But anyway, we've got like 50 measurements of the true position at the time of occlusion intersecting with an elevation that corresponds to no drop over distance every time. So in other words, the globe is failing to make the correct occlusion prediction, and the flat Earth model is making the correct prediction. In other words, the stars aren't physically changing elevation relative to you. It's an apparent change, and that's noted by the intersection difference between our two models for the occlusions. Go ahead.
So, what do you think about that, Green Knight?
Yeah, I'm curious what the mechanism for this. What did you call it? Astronomical refraction. Like what's producing that?
Cooked.
Oh, well, you're asking about astronomical refraction. That's a great question. So
Yeah, I've never heard of that before.
Yeah, so it's different from terrestrial refraction. So if you were like a surveyor or doing things on the ground, anything below your eye level is considered terrestrial refraction. And the way that they calculate that is by lapse rate, which is basically just temperature and pressure in a vertical reading. So like as the gradient changes as you increase elevation, that's what they based how much terrestrial refraction there's going to be, and that extends. I forget the exact amount, but at some point, as you get higher, it starts to drop off, like a few hundred, or not a few hundred, like a few kilometers up. It starts to drop off, and then it becomes like, quote unquote, this is their terminology. It becomes disconnected from the layers above it, which would be like the tropospheric layers and whatnot. So they have a different computational model for how they compute astronomical refraction, and that is the amount. Astronomical refraction is the angular difference between the quote unquote true position of the star and the apparent position, which is the the light that you do see. Now, the 15 degree per hour position the true position follows 15 degrees per hour, and so it'll complete a full circle in 24 hours. But the apparent position, as it gets lower in elevation towards the horizon, it stops following that relationship. So what they have is it's a literal curve fit formula that they have that starts. It has temperature and pressure in it to start, like with the baseline, but the rest of the variables in it are computed via curve fit to make it be whatever it has to be to maintain the 15 degree per hour relationship. So earlier when I was telling you about how you can go into stellarium and set a star, and you could watch the refraction amount increase as the true position gets more negative below the horizon, it comes up to about 30 to 33 arc minutes before the apparent position also goes negative. So they basically invoke however much refraction they need, not as a measured amount through any sort of empirical readings, but to curve fit what it has to be. And I've read through what would you call it? Like the papers where they talk about how the formulas and everything are derived for all of that. And it starts with a computational model, assuming the radius of Earth. And then they start off at the center of the ball with zero elevation, and then they build the whole ball up starting from the literal center of it all the way up to the surface, and then they extend it 20 kilometers past that, and they have a whole smooth static gradient that doesn't move, conforms to sphericity and all that. And they make some air density assumptions that make it all so that whatever they need the angle to be basically is what it'll come out to be to maintain usefulness on the globe. That's kind of what Shane was talking about earlier when he was saying that they say that that's a linear relationship for the 60 nautical miles per degree, but that only exists in a certain wave band. That would be about 65 to about 30 degrees in elevation. Right around there, you'll see like the lowest amounts of quote unquote astronomical refraction, meaning not much angular separation between the true and the apparent position. But as it gets lower in elevation, in particular sub 15 degrees, that's when all their computational models kind of break down, and they have to use these specific curve fit formulas that are tailored specifically to explain the angular difference between their 15 degree per hour rate and what's observed. And so we have a really nice way to test that based off of occlusion timings, because basically if the star is setting into the mountain, there's no difference between that and how it would set into Earth curve for the observer. So if they go as far as to say that a star could be refracted up above geometric ball curve by 30 arc minutes, then it should definitely be able to be above a mountain peak for an extended period of time before it actually gets occluded for them. So we can test that with these measurements.
Okay, sure. So if I understand what you're saying, it's that not only does this phenomenon exist, but the degree to which this phenomenon exists depends upon how high up in the sky the observer is looking from whatever position that they're at. Is that correct? Is that what you were saying?
Yep, and the cause of the phenomenon is like what's in contention here. So like you guys would say atmospheric conditions, and make all the assumptions about the air density and all that stuff to get the formula to fit to fit what's observed. And we would just say that it's an optical effect, as like we don't see in perfect spherical vision, we don't see in perfect linear vision. It's a combination of the things. It's actually since the late 1800s, there's a lot of studies on optics and perception and how we perceive things, and there's various models to model out vision, and they all fail at different distances and in different circumstances. So we kind of take the position that it's more of a logarithmic scale, where it has, you know, linear portions, hyperbolic portions, and extreme curves, and then it goes asymptotic, which the asymptotic would be where the star is close to the horizon, but it's not setting at that same rate, and it's just kind of lingering. We assert that that's because the star is just, you know, moving away from you, rather than, you know, going down, you know, because of ball curve.
Right. So if what you're saying is true, and that rate will vary depending upon how high up in the sky that you're looking, why does that? So that would also predict that as an observer moves from, you know, along the surface, you know, east to west or north to south, etc., the rate at which stars move across the sky would change, even though the observer is moving at a constant rate across the globe. But we don't see that if we were to do that, right? Like it is in fact a constant rate. So why would you hold to that model if that doesn't predict what we would actually observe?
Yeah, it's not for the apparent position. That's why they have the extreme corrections when they get low to the horizon. They don't follow that linear relationship.
Right, but did you understand what I'm saying? According to your model, the rate at which those stars are observed, you know, moving in the sky would change.
Yeah, that doesn't happen. It's the exact same.
But that doesn't happen.
It's the exact same as what we observe now. There's no difference.
No, your model would in fact predict that, you know, as I move from east to west, at a certain point, as those stars are moving in the sky, the rate at which they climb, you know, according to the observer's perspective, would change over time. Like it would start small, and then it would look like the stars are actually accelerating higher and higher into the sky, even though you're moving at a constant rate, right?
No,
but that doesn't happen.
No, I'm not sure what you're saying. So let me try and break it down, like what's happening here. So there's a latitude dependent variance for the apparent position, right?
Right, and that a latitude dependent variance would be predicted by a global model. Yes.
It's also predicted by a flat Earth model, because what we're seeing, right? You think you're looking directly at a star, whereas we're saying that's the apparent position of it. So there's no, like, it's not an issue for us.
But it is an issue for you because of flat Earth model. You would actually predict that everything is visible at the same time.
No,
I'm sorry.
No one would predict that.
One second. No, we don't. Well,
no, stop muting me.
Listen. When we were discussing earlier about the whole radius of vision thing, that's what creates the latitude dependent effects from the source of whatever is projecting the stars. That's our position. So the latitude dependent observations aren't mutually exclusive to anything. What is mutually exclusive is the occlusion timings of stars. Because if the Earth is a globe, as asserted, and if the globe is truly the causal mechanism of latitude dependent observations, then there must certainly be a difference in occlusion timings. Would you agree? Like if the mountain's physically lower than you, and the star is geometrically aligned with the globe earlier, because it, you know, that's what it predicts for the geometric intersection, would you agree that the globe has a different prediction timing for an occlusion than what flat Earth does?
Yes, and the problem is that, as you just said, that astral refraction effect is greater as as you're observing something higher in the sky relative to the horizon, right? So the effect is smaller at the horizon, and it's stronger as it moves higher.
No, much greater at the horizon. You got it backwards. But
okay, all right, that's fine. That's fine. That's fine. But it's variable in either case, right? Like it's greater at the horizon, and it's smaller as you look overhead.
Right, but we know
as you move.
But the important part.
Please, I let you speak. Please allow me to speak.
The important part, though, is that we know how much the time difference is, so we still know the exact rate at which it happens. So it's not like a mystery, right? It's not sneaking up on us.
Right, but what you're saying is that rate is variable as you move along any given latitude line, correct? But it's not in the reality. Like if you were to move from east to west at, like, let's say 400 miles an hour, your model would predict that as that star is moving from the horizon to, like, let's say, 30 degrees up in the sky, it's going to be moving at a X rate. And then 10 degrees after that, it's going to be moving at a little bit less than X, X minus 20%. And then an extra 10 degrees, then it's moving X minus 40%. But we don't see that. That's not how stars move as you move along a latitude line. It's a constant.
Yeah, there's not a rate that we predict that's model dependent. That's just the rate of the stars. And because we know the rate of the stars, we know that there's going to be different occlusion timings per model, which is the important part here. So now that and also
your model is not predictive, then like what use is it? You're
Oh.
just cludging together like
well,
fairy dust to try and account for the fact that like your model behaves exactly like a global model, but
Ooh.
you'd like to claim that it's not.
Well, but it doesn't.
Well, here's the thing though, right? We have already established there's going to be mutually exclusive occlusion timings. And number two, we actually don't use the apparent position. We use the true position for the intersection to get the occlusions. Like the same way that they predict eclipses. Did you know that when they predict eclipses, they use the quote unquote true position of the sun and the moon, which just means it's unrefracted position as if there was no atmosphere. So they make that for their prediction, and then there's some variance in the angle in which you see it and whatnot due to actual conditions and whatnot. But the actual predictions are made using the true positions. So what we do is we reference the star's true position and when it's going to geometrically align with the peak. And now for every example, like I can send you a spreadsheet if you want to take a look at the data real quick. I know it would be hard to try and make a bunch of examples that you've never seen and stuff before or whatever, but the globe has a certain intersection window for timing, and it's never hit its mark even close. It's often off by 2 minutes, 1 to 2 minutes. And our predictions are always way less than what's predicted to be off. So like, for example, for the one I was kind of talking about earlier with 50 kilometers in difference with 200 meters of elevation difference, the globe predicts an occlusion like 2 minutes and 30 seconds earlier. And they were off by that entire amount. Whereas our prediction, keeping the 200 meters of elevation, we were only off by 11 seconds. And that trend continues for all measurements. The geometric intersections don't cause any occlusions for the globe in the way that it would be necessary for it to. Because like the way that it works with central angle and all of that, I don't know how familiar you are with the backbone of the globe and whatnot, but basically there's a specific amount of curvature per distance. And the difference in our measurement is the globe will be off by most of Earth curvature, or it'll be off by 2 to 3 times the amount of Earth curvature, whereas we'll only be off by, way less than that. But the difference between what we predict in our measurements and what's actually measured comes out to be the half central angle. So we know that what we're doing is like mathematically solid, and it's a good model comparison because our error difference is the same half central angle. So whatever we derive based on the occlusion timing, like we share that same common error, and the error is always on the globe side, meaning you guys missed your occlusion intersection window. So the whole hypothesis about the stars have to behave this way because it's a globe exclusively is untenable, because if it was and it did behave that way, then the occlusion timing, it would be the reverse essentially. We would share the globe curvature error, and you guys would be way closer, and I would be on here arguing celestial theodolite in the globe position stance.
Remember when I said you're going to ask the same question to demonstrate you weren't listening the first time he was speaking? No offense, this is kind of hard stuff to get the first time, right? But you're just saying the stars don't work on a globe or on a flat Earth like they would on a globe, and you can't even articulate a question as to how. You're just saying, nuh-uh. That's what at least I'm hearing. Can you understand what Alan's saying about the time inclusion, Green
It
Man?
sounds like you're not really listening to what I'm saying.
Well, can you hear about? Do you know about the
It
time
sounds like my
inclusion?
question went over your head.
He's explained to you the time inclusion 3 times now. Do you know what he's talking about yet, or not?
I've asked 2 different questions that have still remained unanswered. One, the first was the mechanism that accomplishes this effect that you're trying to describe.
It was answered immediately. It's the radius of vision.
The second question was, as we as observers were to move east to west along any given parallel, we would expect, according to your model, that the stars would move at a variable rate as they go from the horizon towards the apex of the sky. But that's not true. That's not how stars work. As we were.
Why would that have to be the case? That's a straw man.
Boat.
That's a straw man. Why would that have to be the case?
He literally said that would be the case because the effect is stronger at the horizon than it is at the apex of the sky.
Yeah, when
that's literally his word. So no, but please answer either of those questions, and if you can, I'll leave here more convinced of your position, right?
So for the
but
third,
if
time,
Stonewall, if you go off on
make sure you have your
hole,
ears open this time. So for the first one,
please,
the radius of vision, right? So if we have a radius of vision, it's going to create the same latitude-dependent optical effects that you would be asserting is globe. And for the
so
go ahead.
Here's the answer you should be phrasing. The mechanism that accomplishes this is, and then you describe the mechanism.
The mechanism that accomplishes this is the mechanism for this is you have a radius of vision, and then I talked about how
this is a concession as far as I'm concerned.
Dude,
buddy, look at your follower count compared to his.
So when I was talking about the radius of vision and how since the late 1890s they've been coming up with different models to describe how we see things, because basic way to explain it would be train tracks appear to converge at a distance, but we know that they're physically parallel. So there's different models that have been proposed to explain why they don't follow Euclidean geometry, why our vision doesn't follow Euclidean geometry. And so there's spherical models, there's hyperbolic models with negative curvature. There's what's the other one? There's the Vith-Muller torus, which kind of makes like a latitude and longitude sphere. So it's like as you look further out into the horizon, there's more optical compression is basically what they're saying. Like the further things are, it's the rate of which things optically compress. And then I talked about how our position is that it's not negative curvature or spherical curvature. It's a logarithmic scale that's, kind of dynamic, and at different elevations or distances and sizes and whatnot, there's going to be different scaling to how that applies optically. That's our position. So when I went over that twice, and then you said that's never been answered, and haha, and kind of scoffed at it, and then called it a concession, it's like that makes me really bored and disinterested with the convo, because it made me realize that when you agree that there's different occlusion timings, and then you found out that all the occlusion timings don't actually go to the globe, you didn't have any interest in that. You started going back to things that were irrelevant. You started saying that if you move at 400 miles per hour laterally, the stars are going to like all this dumb shit. And it's like, dude, if you don't want to know the data, then don't fucking, why are you here to ask about it? If you're like, if you're just going to be like, I didn't hear anything, it's stupid.
Imagine having the hubris. Imagine having the hubris just to laugh as soon as you start talking for the third time after you ask the third question, and he can't steel man one thing you said. He can't. He has no clue what you're talking about, and he laughs in your face. It's really, man. It's not the way to approach any argument or any discussion.
Yeah, I honestly have no idea what you're talking about with your spreadsheet. It sounds like you're trying to describe instrumentation problems and bad math related to that, but without actually looking at this GWiz spreadsheet, I couldn't say for certain. But
I will link you this.
Compelled to point out, you still have not provided a mechanism, right? The thing that does this. Like, what's the thing that does that? You're just describing what your observations are. You're not
your eyes. You have a radius of vision.
So why don't my eyes do that all the time when I'm looking at things that are, right overhead? Like planes don't do that either. So like, what are you talking about?
Buddy,
did you not understand when I was talking about how it's not a linear relationship at different angle sections? There it's linear and then not linear, etc. Like the whole conversation, it seemed like you absorbed none of it, or even bothered to ask for clarification on it. Like if you didn't understand what I was saying, so like
but that has nothing to do with my question. I'm interested in the answer to my question, and you're just waffling around and refusing to address it. Like you're going off.
I think what he's trying to say here, Alan, is he doesn't like your answer
without actually describing.
So he wants you to keep repeating.
I'm begging him to stop repeating himself. All he's doing is answering my question.
Hey, everybody, hold on real quick. Stone, for some reason, it's not letting me bring you up here. Try to reset and come back. But you seem to be aggressively misunderstanding or not listening there, Green Knight there. Is
I'm
there a
listening to
specific?
everything he
Yeah,
says.
I don't really think
He,
you are the way you
but he's not listening to my
the way you
question. He's
keep on
refusing to
interrupting
answer, and that
everybody when
speaks for
we're just
itself.
talking, so you can just keep on muscling on through, dude. I don't know what your problem here is, but if there was one specific point that you got lost on that we can go over for you, maybe stick with that, and then we can go on to a second point. Because
Yes, what is the one point is what is the mechanism that accomplishes that?
Your eyeballs, man. You're looking through stuff. You're looking at
Okay,
it.
great, excellent. So
You
as
know,
a plane
so
moves
let me ask you a
from the
question here.
horizon
Hey,
to the sky, we should
green,
have that same
green,
refractory period.
green. Stop. So would you agree
Really
that
tense. Are you
dude,
okay?
no, are you okay, dude? You just seem to want to talk over everybody, bro.
Yo,
It's
I
not.
can't stand this
You-
talking
you-
over everyone dog shit. It's like it's literal audio diarrhea.
It really is, dude. So
You're talking nonstop.
dude, you're literally doing it every single time somebody speaks, man. I'm going to be talking here for a minute. I'm going to ask you a question. While I'm doing this, mute your mic, Green, please. I appreciate it. So we have a mountain on a flat plane. That peak of the mountain is going to be in a certain position. If it's on a globe, it has to be in another position. Would you agree with that statement?
Sure, but this has nothing to do with my question.
It has everything to do with it because we're
No,
talking
in
about
fact, it
optical
doesn't. I asked a
phenomenon
question
and
about
whether the
planes, and you're
change in
talking about
elevation is
mountains.
physical. It sounds like you're talking over
I'm
me.
asking about
And
planes.
man,
You're talking about mountains.
Every time I've tried to even talk about the
Is
plane,
a plane a
you
mountain?
started talking over me, dude. I'm not going to play games with you and play the who can talk over one another the most.
All you're doing is
because that's one of my favorite
terrified
games.
of answering my question.
Hold on a second. I'm going to go ahead and let you ask your question incomplete. Everybody, don't talk over this guy. Let him ask his question. That way we can all hear his question. That way he can't say we didn't hear his freaking question because he wants to say it a flat plane now. So continue on with your question. That way we can hear it 100% for you there, Green Machine.
You'd like me to repeat my question?
Yes, I would like you to repeat your question. That's why I said
repeat the
question.
So if after I repeated myself
yes,
4
I would
times,
like you to repeat the fucking question.
Why are you cursing and screaming, my
Because
friend?
you're fucking annoying right now. All right.
You seem kind of triggered.
No, I'm not triggered. Ask your question.
Yeah, how about you just give us your
I'm
damn
not triggered. Don't
question
print in the
and
papers I was triggered.
Quit crying about how many times you got to say it.
I'm not
So
crying.
anyway,
I'm
again
regarding
regarding
it was
the
actually this
plane,
easy. So here's the question.
Dude, you gotta stop. Can I just answer the question? I've heard it 4 times.
Sure,
I don't need you to ask it
he
again.
just told me that
You're
I should
asking
ask my
about
question for everyone, and you're speaking over me. But go ahead. No, please.
I don't care. I don't care. So listen, for the 5th time, and I'm going to try and answer this now regarding the plane. The plane doesn't move at 15 degrees per hour. That's a celestial body. They're way higher in altitude than the plane. And secondly, the planes go like when an observer is looking at the plane at its zenith, and there's an observer, much further away, and the angle is going to be different for them. They're going to derive different elevations to the physical plane. So none of how a plane moving in the sky and being seen at different angles proves anything. You're avoiding the actual subject, which is the difference in occlusion timings.
Okay, great. So here's the problem with what you just said. Your explanation for the mechanism that accomplishes this, as you said, it's your eyes. So if that was true, then we would expect that same phenomenon to apply to planes because I'm using my eyes to observe them, right? But now you're saying through some method of special pleading that stars work differently from planes, even though I'm using my eyes. So I'm going to repeat the previous question because now we must discard the first explanation of mechanism, right? Because now it's not just my eyes. Now there's something else that happens between planes and stars that you're just refusing to describe. So let's go back again and let's see if you can come up with an answer this time. What is the mechanism that accomplishes this astral refraction that doesn't also apply to airplanes? Go.
It's still the exact same thing, and I don't appreciate the long-winded rhetoric of just hand-wave dismissing my explanation and then slowly repeating your same question so that I get agitated to try and annoy me. So the answer to your question, again, maybe if I speak really slowly like you were doing, it'll it will have the reverse effect. So here's the thing. When the plane is moving above you, it's at your 90 degrees. When it gets further away from you, it's at a different angle. When there's multiple observers viewing the plane at different angles, they're going to get different altitudes. The plane isn't moving at the same speed the stars are moving. So to say that the stars are a special pleating, we're talking about a different thing. We're talking about the movement of the celestial bodies and their known fixed variables that create the globe model. You're talking about a plane flying overhead at different altitudes that has no, and the same optical effect happens with that, as I just went over. If you're looking at it at its zenith, you're going to get a specific altitude. If you're looking at it from different angles, you're going to get different altitudes. These are all apparent positions, and the same exact apparency also occurs in the sky. Now, back to the original claim here that we were talking about. You agreed that there will be mutually exclusive timings for each model. The models that predict the correct occlusions is the flat Earth model. So we need to focus on why the stars are making geometric intersections with an elevation in time that doesn't correspond to a globe Earth model, which, as you asserted earlier, is the entire reason that the stars change positions.
So can we back up to what you were saying before about airplanes?
Nope.
No,
We can back up to
this
what,
rant. You went off on this rant.
No,
You went
we can
off
back
on
up
this
to where we
rant
were talking
about
about the
people
mountains
being
and the
at
stars.
different
It
observers
sounds
being at
like you
different
don't want to
positions.
talk about the thing, and
And
you
that
want to
wasn't
focus
my
on not the
question.
thing.
Well, there's a reason for that. It's
That's so
because you
weird
didn't
that you're not
actually
talking
Bro,
address
about
what
the
I said.
thing.
your questions, bro, just demonstrate you have no clue what the fuck's going on. You can't even formulate a coherent
That's weird
question.
because you couldn't answer it. So what does that say about you?
You answered your question over and over.
Actually, I
No,
think
he
he
didn't.
does
And I'm about to
understand what's
explain
going
why.
on. Actually, I think he does understand what's going on. I think he understands Alan perfectly, and he realizes that the occlusion timings don't match a globe. So he does not want to talk about occlusion timings with stars because it refutes his preferred model. It's evidence against what he has. So instead, he wants to talk about an airplane that does not move at 15 degrees per hour like the stars. It's going to change angles much, much quicker. And he wants to go to something that has nothing fucking whatsoever to do with the shape of the
It has
earth,
everything
because
to
that's
do with the
exactly what
predictions
Alan
laid out
is.
by the
That's
model according to
exactly.
what you.
Now you're going to find out real quick. You're not talking to Alan. You're talking to a co-host, and I can mute you. You can't talk over me. And I was speaking, and I don't care who you think you are, but I'm tired of you just interrupting anybody and everybody and trying to chuckle your way through this. You're ignoring the fact that what he's describing to you is a test of the geometry of the earth. And you're all the things that are used. Your globe fails to predict the occlusion timing. That's the problem, because they're mutually exclusive. The difference in angle to the mountaintop on a plane and that same mountaintop on a curved earth where it's going to drop over distance is different. So there is no mixing of the two. It's either going to match the globe prediction that says the actual location of the mountaintop is much lower, or it's going to match the flat earth, which says it's much higher. And it consistently shows that the occlusion timing matches the flat earth prediction. Now, you can try and skip around it, dance around it, and talk about airplanes all you want. But he's told it to you a bunch of times, and you just don't want to talk about it. So, add something, be constructive, quit being a dick, and talk like a normal human being.
He's latching on to one thing that he said. Oh, refraction's different at different elevations. So now he thinks he's got some big gotcha with being in a plane, but he doesn't understand what Alan's even saying to begin with.
Now his point doesn't even make sense,
I
which
never
is
said
funny.
anything about being in a plane.
Is that Peter? What's up?
What's up, Beasticles?
Oh, I thought it was the bad Peter. Phew, this is much better.
Oh yeah,
Yeah.
I can be the
Sometimes
Freaked
bad
me out for
Peter.
a second there.
Yeah. I was like,
You
no, wait, I
guys
had
don't know how it is on a globe.
No.
Oh
So
no!
so what's the next subject here, guys? Like, is there more land on Earth, or what's going on here? What's the panel saying?
I'm not a extra lanner really, but other
Same.
people are. But
But
doesn't
they could
really
be
matter.
hiding. They could be
I
hiding land for sure, like in the ocean, or just straight up be building underground, which I think they're more likely just building underground. Like imagine
yeah.
skyscrapers, but like beneath the earth.
I just
Yeah.
want to point out to Alan's point, you don't have to be an extra lander to think the Earth's flat. So don't think you got to be on all board with all this stuff. We just see way too far. But I'm all there with you, Beasticles. And yeah, they're showing us with the movies with the Hollow Earth and the bunkers. But something's going on.
Well, we've only explored 10% of our oceans, and who's ever really measured the oceans? And we don't know how big those suckers are. So who knows what's out there? There's a reason why we don't get to go very far. But do you understand what's going on now, Green Knight? There, are you still lost?
Well, I don't think you listened to a thing Alan said about the cell Theo and physical occlusion timings.
I find that accusation hilarious after someone got on and said that I was talking about someone being in a plane. It's so clear that as time has gone on, how little you're absorbing about what I'm actually asking.
So, are you
As you
able
go
to?
back to, as you start screeching and jumping up and down about your occlusion timings table, instead of
Well,
answering a very simple,
dude, I don't know what your deal is, but I asked you a question. Are you on? Do you understand what was being told to you? Yes or no?
yes, and I directly addressed that earlier when I
Can
was
you
describing
can you
instrumentation
can you
problems.
can you do us a
Yes,
favor?
your claim is that you're
Dude, stop interrupting. What the fuck is wrong with fucking people? Seriously. Can you steal, man, what Alan said, please? So we know that you know.
yo, wait. Your actual response. Hold on, I didn't catch that. You're right. Your actual response to what I said about the timing difference was instrument error. That's what that you said. That's what your reputation
sounds like that's what you're trying to describe. Yes.
Okay, I just wanted to make sure. Okay, thank you.
He
So
smoked a joint and he hopped in here. Okay, guys.
hold on a minute there, Canada. There, can you steal, man, what
Wait, that
Alan?
was your rebuttal? Performative outbursts of laughter? Could you explain
Yeah,
Do you know
why
what a
that's
steel
funny?
man is?
dude. Seriously, are you even an adult right now, dude? Can you steal, man, what Alan said, please?
Yes, his claim is that his model better predicts this factor called occlusive timings than a global model, which I have seen absolutely no evidence of, and I have no reason to believe. Describing some spreadsheet that you have on your computer is not convincing in any way, especially when I'm asking a question about a real world observation that anyone can
Yeah, that's what
recreate if you're just on a
that's what
plane
the
or a boat or even in a car,
that's what
to be
listen
honest.
that's what the
Now,
listen
hold
man.
on, conspiracy. Hold on. Get it out of your system there, Green.
Well, wait a second. Was my steel manning accurate?
No, you
No.
weren't even.
Okay,
No.
then please correct me. Tell me where I
Well,
went.
it only goes to how many times did Alan go over it? Like 4 times?
He said
It's
he didn't
only
even name the
Five.
term right. Like he
He went over
couldn't even
5
No, I
remember
mean
the
he
times.
term
said he went over
occlusion
it 5
timing.
times, but he didn't. You can run back the tape
Occlusion
if you
time.
disbelieve me, but I'm right.
Yeah. You seem to think that it's just something that he has on his computer, like he's just working up some
No, I
theoretical
don't think he
model
did it. I
and he's
think some
working
other
it out on
flurfer
his
did it.
computer. These are real life
Right, some
observations.
flurfer observations. Got it.
No, anybody can do it.
Well, listen, if I
You
were
can
you, I
do it.
wouldn't want to address it either because it's terrifying and super, convincing,
So
concrete,
far, all this
independently
guy's giving
corroborated.
us, sorry, Shane, but it's more than I can handle. So far, all this guy's giving us is sophistry, gaslighting, right? And now ad hom about what
And a bunch
flurfers
of
took the
questions you simply
observations.
can't
Oh,
So
answer.
we must
And
not have got it right because we're
Listen, man,
flurfers,
well,
right?
condescending
Still waiting for an
dickwagon too.
just real quick for the 10th time tonight, man. Listen, a star goes behind a mountain. That's called the celestial theodolite. Based on the time the star goes behind the mountain, determines whether or not the curvature is there. Do you understand that? You said you wanted real life observations. That's what Alan's been trying to tell you for the last 20 minutes. Do you understand that?
I'm asking a question about airplanes, and you're running back to mountains.
No one
I
cares
asked
about
you a
the
very
airplane.
simple question, man. Do you understand it? Do you understand the fact
I
that
care
star
about
goes?
airplanes. That's my
Are
question.
you
If you
listening
can't
at all?
answer it,
Are
you're
you?
conceding the argument.
Yo, get rid of this guy.
Good,
Yeah,
get rid
you're
of me.
about,
Concession
dude. You're about to
accepted.
get
Have a
bounced.
nice day.
Yeah, yeah. You should just excuse yourself, dude. Yeah. I mean, seriously, that was pretty weak. I mean, seriously.
Instrument error,
Yeah,
dude.
he's gonna say
Well,
he's gonna talk shit to Alan about laughing at something that he said about instrument
well,
error
notice
when he doesn't even understand what Alan was talking about in the first
Yeah,
place.
no,
dude.
Because my question is, what
no, he had no
instrument?
intention
Well,
of listening though either.
well, there is air in the measurement, but it's not to the tune of exactly Earth curve. That's crazy. So like that was just like a way to hand wave dismiss it or whatever. But yeah, there is small variance in the measurement, but not to the tune of I don't know exactly what the Earth would be if it's a globe. Like that's retarded.
Yeah,
It,
I don't think he actually understood it like enough to even hand wave. He didn't know what he was hand waving and dismissing. He didn't even know.
I couldn't even say it. But dude, his only I think if I could make out his argument was a completely different straw man where he said that all the stars would have to proceed at different rates because everyone sees forever with superhuman eyes and orthographic lines that extend in perpetuity, violating the actual light attenuation, atmospheric opacity, and the inverse square law. I think that was his actual position for why it should look goofy to us. And then I think I think he made an argument out of that, and then was upset that nobody was addressing his retarded made up horse shit. So that's weird.
I think the only thing he agreed to is that the mountain peak would be at a different position on a flat plane in a globe Earth.
Yeah, that seemed like he could not agree to it, which is why you got like the tacit agreement and then the quick deflection to something unrelated.
You want to talk about airplanes?
yeah,
You want to talk about airplanes? Like, bro, no one gives a shit about your fucking airplane right now.
you guys did a good job
I've
of
been
articulating
discussing.
the argument with the timing difference. That is the most important part of it. They predicted different eclipse time. Essentially, you can think of it like eclipses. They predicted different time.
I've been discussing with way too many Zionists and Hezbollah accounts to not realize after like 20 seconds that he's Jewish. And it's the exact same quetching, over talking, deflecting. Basically the Hezbollah handbook on a global Earth model.
You heard him as soon as he came in. I'm like, I bet you think the Earth's a globe, and then it was right off the. I mean, I kind of shots fired, but yeah, I'll just land there.
You can always tell how hard
Actually,
they
I kind
believe
of
in the
blame it on.
globe because their proportional response to conflating contrails with chemtrails is insane. Like you can see a normal chemtrail dissipate in like 20 seconds. It doesn't leave a streak across the sky that lasts the entire day and then some. Like that's that's such a disingenuous conflation. Like even normal people, like you can go out, watch a plane, record the contrail behind it. It doesn't last for the like it's basically trailing the plane essentially. It's a different thing, and they're like, nah, they're the same though, and you guys are dumb. It's like, oh, you have a nice big bowl of mainstream media and you just eat it every morning. Is that what's happening?
Well, it's valuable too to thoroughly place. The listeners get to hear, because they come in so confident and then they run away. Sorry, go ahead, whoever that was.
Well,
No, I was just gonna say I blame it on Alan because Alan gave him the senior in college explanation. I think he should have went back to like the 8th grade explanation of celestial
Dude,
theodolite.
Yeah,
he had
I don't think
exuberant confidence in the globe, bro. He was asking for it.
Dude, how many
It was
Glovers do you think are proficient commonly with central angle theorem and its actual importance in their supposed globe
dude,
model? Like off the
dude.
cuff.
The
Yeah,
way
right. Yeah.
the way that they talk to us online and make claims about math and shit, all of them should be special angle theorem
yeah.
specialists, bro. It's literally the first page in Smart's astronomy book. If you go to spherical trig books, it's like the first thing they cover about how angle equals distance and all of that. Like they better be experts in it if they think they live on a globe. If
They
you think
don't
you live
have
on
to
a globe
know
and
it,
you
Alan. They other smarter men know it. Therefore, you're wrong. I mean, I can just lean on that. Like, come on.
And
Well, we
other
got an
smarter
airplane.
men are being referenced by a smarter LLM. My LLM is better than yours. My chatbot wins.
Hold on, let me ask Rock if I could just conflate and confirm my opinion bias real quick. Hold on, I'll be right back.
Grok, how do I shit on these flurfs?
Is that TM's?
Hey, we've got
TM's? What's up?
What's up, guys?
Brownhound does that.
What's that?
I know y'all were seen Roundhound and a couple of them things talking about the celestial theodolite. He'll pop in and ask questions and Discord.
nice.
But as soon as
And
sorry, Ken.
I've literally watched him in the timeline say, "Hey Grok, how many of these flirts have I debunked?" And he's getting Grok to answer his questions.
Dude, somebody, I think it was, I think it was KJ. I think it was KJ pressed him for his source, and it came back to some account that had like 7 followers, and that or he was following 7 people and had like 2 followers, and one of them was like Elon, the other one was Jesse Path of Light. I think it was a Jesse. I think he's getting his information from Jesse Path of Light. Round.
Grok, what was my kill count on Modern Warfare 2 in 2010?
Right?
How many Jessies have I killed in Halo? Could you give me the count?
I have a question, guys. I'm a newbie here. I was in earlier. In the flat Earth model, how does the sun and moon work? I've seen pictures and diagrams of it going in sort of a elliptical circle. Is that and if the sun is not as far away as they say, what do we think the sun and for that matter the moon is? What are they in relation to this plane?
It's a good question. I don't have a good answer for it, really. There's only one thing. Well, there's 2 things that we know about the sun and the moon. That's their angular size and how fast they go across the sky. So using those 2 things, you can see how long it takes for the sun and the moon to traverse their own diameter, and from that you can derive the diameter. So with that, when you do that for the sun and the moon, since they're the same size, they come out to be 32 to 37 miles wide. And then there's also a thing you can do with with the celestial theodolite and using an elevation that Brian derived to get the same kind of 30-mile wide relationship there. So it comes out to about the same with the only known variables that we do have. And those that like a 30-mile wide sun isn't big enough to light up the whole earth and do what they say, or what's observed rather. And so I take the position that the sun and moon and all the celestial bodies and all that are individual to us, like how we perceive them, and their actual sizes and actual altitudes and whatnot. Like physical altitude in terms of like meters is unknown to us, and we'll never really know it. And when I was looking through the history of Japan and China for their cosmological beliefs, they actually thought the same thing, that the heavens were, had true positions that were unobtainable for our human eyes because of like various philosophical reasons that they would say. So like the Chinese ended up saying that we have a limit of vision, so how we see the heavens isn't 1-to-1 to their true positions. And then the Japanese kind of had a similar thing where they, we're saying that that the reason that the heavens were obfuscated from us was because we're not like, pure enough to view them, and you have to do like meditation and gain clarity and to see the quote unquote true heavens and whatnot. But obviously, you can meditate all you want. I don't think you're ever going to see the true position of any of the bodies, but that's how they were internalizing it and dealing with it. I don't think it's something that we'll ever know. I think this whole mathematical concept of asserting like this is a rock and it weighs this much is all a new thing pushed from the Royal Society coming out of the late 1800s.
So is that when the globe model was really pushed? Was and at the end of the 1800s?
I think so. We're told a slightly different timeline, but when I was going through the history of China and their, they basically invented the celestial sphere. They invented using a unit like an arc in the sky as a distance on the ground. It was called a li. So like they had all this same concepts and everything. They had their own star catalogs to use the celestial spheres. They mapped out the north, and then they did an expedition in 1421 to 1425 in the south, where they got a zenith measurement of Canopus and used two stars that lead the Southern Cross that point to the South Pole, or in that direction, as their reference for the South. And as geocentric flat earthers, they mapped the entire South after that, or with that zenith measurement from Canopus, because what they did, or the purpose of the zenith measurement was to establish a 60 knot, or well, it would be lees for them, so a 60 li per mile. Oh fuck, they wouldn't even have miles. 60 nautical lees per li. I don't know what it would be, but anyway, they were having that same relationship that Polaris has with 60 nautical miles per degree. They were mapping it to that specific star Canopus in the south, and they just navigated with two hemispheres of two star maps to represent both hemispheres, merging them together. And so like by the time the 1600s rolled around, that's when the Jesuits say that they discovered China and were interacting with them and whatnot. And so they say that they showed up and fixed the Chinese calendar by 12 seconds because their calendar was off, and they made all these map corrections and stuff for them. And they kind of like retell the story as if when they showed up, the Chinese were kind of like desolate and retarded and forgot how to do all their astronomy stuff. And these brilliant Jesuits, helped them fix everything and convert to a globe, essentially. The Chinese didn't accept globe theory until like the late 1800s as well. And they encountered the Jezzies in the 1600s with the same identical coordinate system and method of navigation that the Royal Society, / the Jesuits now propose as their method of navigation that they introduced to the Chinese, which is crazy. They introduced the Chinese to their own method. It's kind of like that movie where the car salesman sells the last car on the lot to the guy that owns the car dealership. It's like doesn't make any sense.
So I've also seen models that there is, land beyond the Arctic ice, and we're actually surrounded by Arctic ice. Is that true?
Oh, I have no idea about any of that. All the maps that show that kind of stuff don't have latitude and longitude on them. If they don't have latitude and longitude on them, they're not for navigation and they're just art.
So in the flat Earth model, we still have latitude and longitude.
I mean, if you're gonna find your way around the terrestrial ground using the stars, latitude and longitude is a perfectly fine coordinate system to use. Now, I'm not saying that other lands and such don't exist, but I'm saying for practical purposes, navigating the quote unquote known lands using this coordinate system, there wouldn't be, there wouldn't be any extra things. Like, how would you get there to them? You know what I mean? Like, if you don't
an
have
abstract spherical coordinate system is model independent, right? You can use it either way. I would argue. In which case, how would you differentiate an abstract spherical coordinate system from spherical Earth?
occlusion timings based on elevation differences.
So another question I have is, I had a guy work for me who was a Marine sniper, and he took me out shooting, and he was talking about, when we were sighting in the scope, he was talking that some of the measurements figure the curvature of the Earth. Is that just a mathematical, bullshit that they're putting on us for
Yeah.
calculating trajectory of bullets?
Yep.
Man.
So that doesn't even really mean anything. Like if you see the target and you shoot it, the bullet hits it. They're not shooting an invisible target that's obscured over Earth curvature. That's preposterous.
Yeah, it doesn't even make sense.
It would have been a better claim to say that they were accounting for Coriolis or something, but that would be a directional dependent shot. So if you're shooting north or south, that's going to affect the Coriolis or that's going to affect your shot the most, and that's not something that anyone records or does or tracks or anything.
So check this out, man. Check this out. This is actually from a Marine Corps sniper.
All right, so I'm here with Mike, who's a former sniper with the military at our Flat Earth meetup at Gather Greenville. And Mike's going to tell us a few things about whether or not they actually account for curvature or the Coriolis effect when they're actually performing their sniper duties. So I'm going to turn it around to Mike and let him talk with you. This is Mike, everybody. You can see he's a legit sniper. So, Mike, do you guys account for the Coriolis effect? Never. Never at all. What do you account for?
Windage, size of target, distance to target, temperature, ambient temperature, elevation of target from shooter. Never Coriolis.
Do you account for curvature of the Earth at all?
Absolutely not, 100%.
Well, you do account for the parabolic arc of the bullet, right?
That's right. Holy crap.
Yeah. Gotcha. So everybody can hear from the mouth of a U.S. sniper that they do not account for this Coriolis effect. So that argument can no longer be used. If you continue to use that argument, then you're doing so falsely. Mike, thanks for being here. We appreciate your service, and we appreciate you.
So, I mean, snipers never account for Coriolis or Earth curvature. And if one told you they did, they're lying.
Well, he was just helping me put the numbers into the app to calculate this specific round to what we were shooting. So maybe I could have misinterpreted what he was saying. I just remember him talking about curvature Earth and Coriolis, whether or not he was actually accounting for it. I could be incorrect on that. But thanks for sharing that video. Appreciate it.
Man, I've taken a lot of long distance shots. I never even thought about Earth curvature. Ever.
Yeah, maybe he was talking about the ballistic curve, but not Earth's curvature.
Yeah, the parabolic curve is,
Yeah, you may be correct in that.
Yeah.
Ooh, I got some gravy on the parabolic curve. Did you guys know that the parabolic curve is a flat Earth approximation? Oh!
It's like throwing a football.
Yeah, so Shane and I found in a bunch of textbooks where they talk about the parabolic curvature for bullets and whatnot. Those are all flat Earth approximations. The only time they actually would use quote unquote globe math for that kind of thing is when something's traveling at escape velocity. So everything that's sub escape velocity is quote unquote a flat Earth approximation, and it's a well-known, established thing. Like that's how they talk about it in literal textbooks. And it's like, so how
well, it's just simpler, Alan. That's not fair. It's just simpler that way. Okay, it makes it easy.
It's just simpler. But that approximation holds, makes the correct prediction every time, and they call it a flat Earth approximation. And they say that the globe, the extra special one is only for escape velocity stuff. So all the time that we've spent arguing over gravitational effects and what a bullet does and it's all flat Earth approximations. Isn't that crazy? And they would like swear up and down that it can't work on a flat Earth. It's not possible. The same numerical value and prediction, my dude. You just didn't even know it. Unlucky.
Well, thank you for letting me come up to the speaker panel, guys, and answer my questions. I'm here to learn more, so I'm going to drop down to listener. I appreciate your time.
Yeah, cool, Mickey. Thanks for coming by. So Canadian News has been standing there with his hand in the air for quite a while, making lots of sound effects and shit. Canadian, you got anything constructive to say or ask?
Oh, is my hand up right now?
No, but
it looked like it was. It might have been an emote, though.
I've been watching your conduct for about 45 minutes now. I figured you might have something to say.
Yeah, Alan, to go back to the extra land, I guess with Admiral Byrd, I guess, in 1950 something. He apparently discovered more land. But when you think about how society is trajecting these days, um, we didn't really have too much taxes back then. And then when people were actually buying houses, there was higher interest rate because when you were lending money, it actually meant something. But now, fast forward to 2025, and they have us all controlled through mass amounts of vaccines, which may be deteriorating our brains, and we're we're now living in 40 to 50% of our life being taxed and having to work till we're 65 years old. But the theory going back to there being extra land and them not telling us, and the 57 nations or so through the United Nations not wanting us to go past Antarctic or not discover past there for scientific purposes. It's just weird, it feels like all the countries together collectively don't want their economies to crash and to be more exploration, because everybody's trapped in this society of pretty much giving their life to taxes. And if you make it out and do better, then I don't know, you're not working till you're 65. But it's kind of that theory as well, to tie into us being condensed into the nations that we know currently. My theory.
Well, considering that they've been trading our productivity on the stock market for years, you can see how really nationalism is nothing more than the practice of how to keep your cows on your side of the fence, if you know what I mean.
Kenbo's got his hand up.
And not
Yeah,
having
so I'm
your
going to take
cow replaced with some foreign goats.
Alan back to the China navigation thing. I was just trying to look some of it up because I couldn't remember everything you talked about. And I just asked Chat GPT, you know, when did China, or did China have a prime meridian? And I was looking for the city, which was Beijing, but that was much later. They were saying that before 200 BC, each observatory used their own north south as their prime meridian, so they had no fixed prime meridian. But from 200 to 100 BC, they started using, and I can't say the name of the city, but it was whatever the capital was under the Tang dynasty, and then they moved it for the Song dynasty, and then eventually they had moved it to Beijing. Um, uh, it doesn't say exactly when, but Beijing was like their last move, I guess, is what. But they're saying that it went all the way back to 200 BC. Before 200 BC, they were using a prime meridian.
I got $5 on Shanghai.
Oh yeah, I didn't even know about that one. The only one I'm familiar with in terms of using for a prime meridian was Beijing. But they're what they did. They started with coming out of the BCs, like the first 200 years of the new generation or whatever it would be, AE, or I can't remember what it is. But anyway, coming out of that, they built an armillary sphere ecliptical mount, or ecliptic mount, which is position like the sidereal positions of the sun and the stars. So whatever they were using, like it's crazy because they just like come out of the BCs like swinging, dude. Like armillary spheres, and then like they further developed those. They made clocks. They made all kinds of stuff. They started doing star logs. They came up with shadow tables, all kinds of stuff within a really quick period of time.
What
Trigonometry,
clocks? Water
yeah,
clocks, shadow tables.
they invented trigonometry as well. Like they have their own their own proof for Pythagoras' theorem and all that.
Might be in correlation with the Aryan migration.
No, we're talking about Chinese people, my dude. They weren't
Yeah,
they weren't
Aryans.
are they Aryans?
Yeah,
I don't
there
know
has
that.
been Aryan mummies found in China and in Japan. DNA, blonde, reddish hair, and blue-eyed.
Oh, interesting. I'm not familiar with any of that. I wouldn't know.
Yeah, it says that
Yeah, the
they
Chinese
use
Jews,
their
bro.
system from 200 before 200 BC all the way up to about 1644, and that's when the Jesuits started introducing their system to them, but they didn't really adopt it until like the 1700s under some emperor who studied with the
Yeah,
Jesuits
so
as part of his
that
education.
emperor whose name I can't remember, but the story with that guy is that he was infatuated with globes, and they would send him, like the Jezzies would send him decorative globes that he would put all throughout the palace. And it was like I remember reading somewhere it was saying that for every room in the palace there was at least one globe, and then it got to the point where um, he had like so many globes that they had sent him that there was like a room that just had a ton of globes in it. And then that guy ended up decreeing that they were going to change their cosmology to globe ball. But I don't think that was until the 1800s, though. If I'm not mistaken. Thought it was later.
Yeah, funny how everything Aryan culture brought forth is tried to be discredited by Jews in some shape or form, almost like it's some biblical feud, right?
No, I don't know anything about that. I just know there's a
I
group of
mean,
people known as the Jesuits that
the
are
Jesuit
retelling history how they want to. I don't know that it has anything to do with the other stuff.
the Jesuit order was formed by crypto Jews in Spain.
Can I live one day in my life without it being Israel's fault?
I mean,
Absolutely not.
I'd wish for it, right? But
At the end of the tunnel of every rabbit hole is a rat connected to the same nest.
Yo, in Veritas, have you ever seen Dune? You ever watched the movie Dune?
dude,
Yeah, but the old ones or the new ones?
doesn't matter. They're always the same.
Doesn't matter.
The Jesuit money. What do they
Both.
call them?
Yeah,
The
if you ever
Benny
watched
Jezzies.
Dune,
Bene
the
That's the
Benny
one.
Gesserit.
Jezzies, the people that basically influence all different types of, governments and populations and control world events and etc. Those people, the Benny Jezzies. That's it's the same kind of people. And guess what? What do you need to know, right? You need to know exactly where you are and how to navigate. That's why the first thing they tried to control was like the land, sea, and air. There you go. China has their own map. We can't let that happen. Here, take this shit.
They were actually wrong. Our map's
T-
twice your
t-
map. See how right we are?
t-
You guys almost
take,
had it.
take our same map given to you in the form of a Mercator. It's like, what?
Yeah, I've seen an old Chinese map from, I think it was the 14th century, with the Antarctica depicted as like being populated with southern hemisphere animals. Very interesting.
Yeah, well, there's the Perry Reese map that was like completed by the Chinese, like the southern hemisphere portion, and you could see because they used to do rumline navigation, and the star Canopus. If you look in the south on that image, I'll see if I can find it here and post it. But where the zenith for Canopus would have been, there's where their rum lines intersect into a circle, and then they go from there. So I'm almost positive that all of the convergence lines on those types of maps, those rum line maps, like the original ones, are all positions of stars that were supposed to be there that were further references.
Dude, shadow tables is the clincher, man. They were like, how do we tell where we are anywhere in the world? Well, as we figured out, you need some sort of latitude or like, the grid system. And they were like, well, when we can't see the sun or whatever, we'll just take a shadow length mark. We'll mark where we are. We'll see how far we go. We'll take another shadow length, and then we'll measure all our shadows from a reference meridian. Essentially, they did the exact same system that we're told got unfolded after John Harrison and his wonderful chronometer, where they decided to tell time down to the second so they could use longitude in the exact same way and set their reference meridian over at Greenwich. It's like, oh, wait, if we just change shadow tables for like a chronometer and water clock, it's exactly the same story, except they did exactly the same thing. They used ratios of an arc minute in the sky to map out the entire world. And all it took was understanding the importance of shadow length tables. So there you go.
What's up, Flats?
Not much. So going back to the category of things that don't exist for 600, that PFP you fought with or butted heads with you on Tuesday and called you the other N word. Later Tuesday, he was in a space with Captain and I, and he claimed he's a sniper. He's a flat earther. But he claimed he's a sniper, and he said there's no Coriolis. They don't account for it. They account for windage, distance, temperature, humidity, no Coriolis. He's like, it would be ever changing. I'm like, what's the formula? There's not a formula. Doesn't exist.
Yeah, the more aligned you are north or south, the stronger the Coriolis effect would be on your shot, and the more aligned you are east to west, the less impact it would have. So if you were going to do like a extreme long distance shot, for example, like what was that one that was done in
2 miles.
was it 2 miles? I thought it was longer than that. It was
4.
No, it was 4.4. Yeah, it's 4.4 miles.
4.4. Holy crap.
Yeah, 4.4 miles. Time of flight for the bullet was like 26 seconds or something like that.
59 seconds. Yeah, wait, 29 seconds. 29 seconds.
Thank you. So 29 seconds time of flight for the bullet. Now, if you were going to like, you're a professional shooter, you're trying to min max, you're not out there to waste time. You're going to go and find a target that's close because you have to control for as many variables as you can. And like dude was saying earlier, what you account for, elevation, well, you can control that. You can pick your target stationary. You're not shooting a man, you're not hunting somebody. So you can choose your elevation differences. You can choose your direction, and you can choose the time and location you're shooting to control for temperature and whatnot, and wind the best you can. But the one thing that you would absolutely do is you have this other variable called Coriolis. So you're going to want to make sure you're shooting east or west to minimize that effect, because the idea here is to reduce the amount of things that are going to make that bullet land in a different direction by as much as you can. So this guy in like 2021, I think it was, got the world record shot, 4.4 miles, hitting a target, and he did not account for Coriolis. And the main feature of that is that he shot what was it? Southwest. He shot west by southwest, like more in the southwest direction, which would have been prime for accounting for Coriolis, because you're diagonal to the plane of motion that you're shooting against. So it would have been a variable to account for. And Jaron actually messaged that guy, because like when that guy got the shot, all these online websites were like, guy accounts for Coriolis and gets world they were all pushing that same narrative. So Jaron emailed the guy and was like, hey, did you account for Coriolis? All these websites are saying that you Coriolis out of your mind. And the guy was like, no, I didn't Coriolis at all. Accounting for Coriolis at a shot of 4.4 miles would be like a 400-pound person buying thinner inner tubes for their bike to get an advantage in a cycling contest. It's not gonna matter. And then so I was talking to a guy named I Can Science That about this, and he was saying that it would be good evidence for a globe Earth that's spinning if the guy shot east or west, because that would mean that he shot in those directions to minimize the Coriolis effect, and any other directions would be evidence, against the globe. And I was like, okay, cool. Well, we'll see which direction he shot. So I had Jaron message the guy to see what direction he shot, and while we were waiting for that, while we were waiting for him to reply, when you go to the website of the shooting range that posted their achievement, you can see the position of the moon at the target at the time of impact. So you can reference from MoonCalc, what direction that was, and it came out to be south by southwest. And that's exactly what the dude said in his reply, because I wanted to make sure that he wasn't going to lie or say something different, and I wanted to have some ammo ready. But his reply back to Jaron was, "Don't tell anyone this, but I shot south to southwest." Now, I can't think of any reason why that man would not want the direction to be publicly known, but I think he knew the implication, and he was like, I don't want to be bothered with this, but just don't tell anyone.
Yeah, and also that same flat Earth sniper, he like I mentioned, the only different thing you would have to account for other than environmental things is the rifling on your barrel, like how many twists there are. That would change the way the bullet traverses to its target. And like he said, yeah, and he also said, he's like, there's snipers that make long shots. He's like, and there's regular civilians that make long shots that don't obviously get taught Coriolis, allegedly. So yeah, it's nonsense. We all know it, though.
Yeah,
Bro,
they have a. Oh, sorry. I was gonna say that they have a book of things that they write down, like all the things they're accounting for. I forget what it's called, but there's a word for it. And it would be interesting to see some of their logs if they ever are like, oh, you know what? I'm at this latitude shooting in this direction. That means there's going to be this much Coriolis. I bet you that's not a single book ever written.
Yeah, and it had to be some kind of logarithmic equation, because it'd change based on your position, your direction, the altitude, everything would change.
Yeah, I don't know if it would be logarithmic, but it would definitely be directional and angle dependent for sure.
Yeah, it'd be ever changing. It'd be weird.
Yeah,
Definitely not normal.
There would be something that's averaged out and pre-calculated, so that if you're facing at this angle, you would have the best chance to account for that force, but that doesn't exist.
And why don't they claim Coriolis with railguns, or do they?
Never heard any of them say anything about that, bro. They say that the railguns are proof of Earth
with
curve.
railguns.
It's insane. They're like, this bullet that's traveling X amount of speed is actually following around a curve.
I think you'd go like Mach 7, the newest one, something like that.
Dude, that's not even an argument for curvature. That's an argument for motion. If you can't see the target, you know what I mean? That's you don't give a shit about you can't see the target if it's over the curvature. You know what I mean? Like it's so weird that people will say that, though. I've heard Globers say that, oh, you're not accounting for the drop.
I don't know that they necessarily would, because you could call it in, right? You would be like, these are the coordinates I want you to hit, and then they would adjust their elevation to dial it in. So I don't know that would necessarily be for or against.
They do